this video, we're going to look at working out the formula of ionic compounds. Now, very important. The number of positive and negative charges must cancel each other out. The first example we're going to look at is potassium bromide. Potassium is found in group 1 of the periodic table, so it has 1 electron in its outer shell it needs to lose, and therefore as an ion, potassium has a charge of positive because it's lost 1 negative particle. Bromine is in group 7 of the periodic table, and it has 7 electrons in its outer shell. So to have a full outer shell and become stable, bromine needs to gain 1 electron, and by doing this it forms a bromide ion with a charge of negative. Now, as you can see, the charges are opposite and the same amount. So in this case, we can just write potassium and bromine next to each other, and this is your chemical formula for the ionic compound potassium bromide. The next example is magnesium oxide. Magnesium is in group 2, so therefore forms an ion with a charge of 2 positive. And oxygen is in group 6, so therefore forms an ion with a charge of 2 minus, the oxide ion. Now, as you can see, the charges are opposite once again and the same amount. So once again, we can write the chemical symbols next to each other, and there is our chemical formula of magnesium oxide. Our next example is magnesium chloride. Magnesium is in group 2 of the periodic table, so it forms an ion with a charge of 2 positive, and chlorine is in group 7, so it forms an ion with a charge of negative. This is the chloride ion. Now, chlorine, or the chloride ion, has a single negative charge, whereas magnesium has a charge of 2 positive. So we need 1 more chloride ion to balance out the 2 positive charges on the magnesium ion. So when we join these together, we form a chemical formula MgCl and then a 2 to show that we have 2 chloride ions for every magnesium ion in magnesium chloride. Our last example before you try some on your own is potassium oxide. Potassium is in group 1 of the periodic table, so has a charge of positive, and oxygen is in group 6, has a charge of 2 negative. So the oxide ion has 2 negative charges, and the potassium ion has a single positive charge. So to cancel out the 2 negative charges, we need another potassium ion. So now we have 2 positives and 2 negatives. So when we put these together, our chemical formula for the ionic compound potassium oxide is K2O, and this forms a neutral compound. Now I want you to pause the video here and try to formulate the chemical formulae for the ionic compounds sodium chloride, magnesium fluoride, calcium oxide, lithium sulfide, calcium bromide, and potassium fluoride. The following ionic compounds are made of these ions. Next, I'll show you the answers. These are the answers. Like the video if you got 6 out of 6. Next, we're going to look at writing the chemical formulae for ionic compounds made up of polyatomic ions. Polyatomic ions are ions made up of more than 1 atom. So these are some common polyatomic ions. And these are the chemical formulae of the ions. It's a good idea to write these down, as we'll be using them a bit later. Our first example with polyatomic ions is potassium hydroxide. Potassium forms an ion with a positive charge, and the hydroxide ion is OH-. So as you can see, they have the same amount of charges, but the charges are opposite. Potassium ion has a positive charge and the hydroxide ion has a single negative charge. So they cancel each other out and we can simply write the chemical symbols next to each other. So this is the chemical formula of potassium hydroxide. Our next example is going to be copper sulfate. Copper can form ions with different oxidation states, but in this case we're going to use Cu2+. You will see Cu3+ sometimes, and the sulfate ion has a charge of 2-. So as you can see, they have the same number of charges but opposite, so they cancel each other out, so we can simply write the chemical symbols next to each other. And this is the chemical formula for copper sulfate. Our next example is magnesium hydroxide. Magnesium has a charge of 2+, and the hydroxide ion has a charge of a single negative. So we have only one single negative charge but 2 positive charges, so we need to double the amount of hydroxide ions. Now we have 2 negative charges and 2 positive charges. However, we have to be careful how we write this chemical formula. If we write it like this is incorrect because this 2 subscript 2 only multiplies the hydrogen by 2. We haven't multiplied the whole ion by 2 like we need to. So instead, we can add brackets. Now the 2 will multiply everything in the brackets by 2. And now we have our chemical formula for magnesium hydroxide. Our last example before you try some on your own is lithium phosphate. Lithium forms an ion with a single positive charge, and the phosphate ion is PO43-. Now we have a single positive charge and 3 negative charges, which means we need 3 lithium ions to cancel out the 3 negative charge on the phosphate ion. Now when we write this out as a chemical formula, we can write it as Li3 because we have 3 lithium ions for every 1 phosphate ion. And now we have the chemical formula of lithium phosphate. Now I want you to pause the video here and try to work out the chemical formulae of the following compounds: sodium hydroxide, calcium hydroxide, lead nitrate, potassium phosphate, copper carbonate, and ammonium nitrate. Here are the ions that make up the compounds. Next, I'll show you the answers. Here are the answers. Remember to like the video if you get 6 out of 6.